Hey guys, hope you all are doing good, and I'm solving one more question for you. October-November session, year 2016. This question is a combination of bearings and further trigonometry, and I'm sure you'll like the solution. And now be confident and all the best for your examinations. Let's check the solution now. Hey guys, welcome back. Today I'm solving the question for you, combination of bearing and further trigonometry. Variant 3, October, November 16. So let's read the question. The diagram shows the position of port A and the lighthouse L, the circle, center L and radius of 40 kilometers. Shows the region where the light from the lighthouse can be seen. The straight line ABCD represents the course taken by the ship after leaving the port. When the ship reaches position B, it is due west of the lighthouse. So this, first of all, what I'll do is I'll make the bearing. So it would be this for B and it will be for L. Now since it's mentioned B, it is due west of the lighthouse. It means that west, if this is north, this would be west. So obviously it will be 90 degrees. So this is the first thing what we know. Now in part A, it is mentioning use the cosine rule to show that angle ABL is 130.1. So I need to show that this angle is 130.1. So I'll simply use cosine rule. Everybody knows the formula. So it will be cos ABL, and that will be equal to 61.1 whole square plus 40 whole square minus 92.1 whole square divided by 2 into 61.1 into 40. So in this case ABL will be cos inverse of 61.1 whole square plus 40 whole square minus 92.1 whole square divided by 2.61.1 multiplied by 40. So when I solve this, right, the angle what I'll get on the calculator, give me a moment, I'll just check out the calculation for you. And I'm just doing this calculation, give me one moment. And so it's 61.1 whole square plus 40 whole square minus 92.1 whole square and divided by 2.61.1 into 40. So yes, here I get the solution. It's 130.1. So first part we are already done, correct to one decimal place, hence I've mentioned 130.1. Now let's say this is 130 and this is 90. Then what will be this angle? I'll calculate because the next part will help you in that. So let's use a simple calculator. It's 130.1 plus 90, and I'll subtract this from 360 degree. So this part will become 139.9. Now since both these lines are parallel, hence this angle will become 180 minus 139.9, and that will be 40.1. So we have calculated this angle as 40.1, and now we will move on to the other part, that is part B. So in the second part it is mentioned calculate the bearing of lighthouse L from port A. So let's see what will be the angle. So this is port A and this is L. So L from A will be this entire angle. So it will be 40.1 and this X. So if I calculate X and I add up both, I will get my second answer, this one. So for this, what I'll do is I will simply use sine rule, and in sine rule I will use sine A upon 40 is equal to sine 130.1 divided by 92.1. So sine A will become 40 multiplied by sine 130.1 divided by 92.1, and if I use A as subject, then it will be sine inverse 40 into sine 130.1 divided by 92.1, correct? And I'll calculate this for you. So on calculation, I'm getting angle A, which is 19.39. So now this part, x, this x is how much? 19.39. So here's my answer, that is bearing of lighthouse L from port A. So it will become 40.1 plus 19.39. So 40.1 plus 19.39, and this will give you 59.49. So approximately I can write 59.5. I'm sure this part is clear. Now the last part. The ship sails at the speed of 28 km per hour. Calculate the length of time for which the light from the lighthouse can be seen from the ship, and give your answer correct to the nearest minute. So it's mentioned hour and minute, but then first thing is I need to find out the distance. So time is distance upon speed. I know speed is provided, it is 28 km per hour. So let's check it out. Now if you just see this diagram, right, I will try to find the value of BC, and that will be the distance. And once I know the distance BC, I will divide that by 28 km per hour and I'll get my answer, and that will be time. So I will join this line. Since they both are radius, it will become an isosceles triangle. This will also become 40. And now I need to find this angle. So it is a straight line, right? This one, ABCD I'm talking about. This is 130.1. So I can find out this. This will become 49.8. 49.8. And similarly, this will also become 49.8 because it is an isosceles triangle now. So sum of interior angles in a triangle is 180. So what I'll do is 180 minus 49.8 plus 49.8 in a bracket, and I will get this angle. That will be 80.2. So this angle is 80.2, and now the questions become very simple. To find BC, I can use cosine rule once again. So what I'll do is I will use cosine rule, and that will be cos 80.2 equal to 40 square plus 40 square minus BC square divided by 2.40.40, and I will make BC as subject, and if I do so, this will go here and it will multiply with cos 80.2. So it will become 40 square plus 40 square minus 2 times of 40.40 and cos 80.2 in a root. So I will calculate this distance BC, and when I calculate this distance BC, it is round about 51.52 kilometers. Now I will calculate time. So time is distance. Distance is 51.52, that is BC, divided by 28, and on calculating it, I will get approximately 1.84. But then this is not the answer for you. So I know hour, definitely it will become 1 hour. And then 0.84, I need to multiply by 60 because I